Okay. Now we'll there's still more coming in. Come on, guys. Okay, we'll continue now. So what we'll have a look at now is sequence and series. Hey guys, come on. Hey, come on. Start writing. As difficult as it is, try to ignore him. Okay? No, as difficult as it is, try to ignore him. Thank you. And you just need to write this down. So we're going to have a look at limits now. So, last week we were talking about sequences which were convergent, divergent, and periodic. Okay? So let's have a look at a sequence, a series as well that's convergent. So we'll take something like this sequence: 1, a half, a quarter, an eighth, etc. So this is geometric. What's the A? 1. And what's the or? 0.5. Yeah, a half, isn't it? So that's the A and that's the or. So write this down and let's have a look at Excel here. So what we want to calculate is 1 plus a half plus a quarter plus an eighth, etc. It doesn't reach it. This is called the infinite sum. So in other words, the n is infinity here. And this is what we want to try and calculate. So let's have a look at that. I'm going to switch to the program now in a second. So if we look here, let me just clear all of this. Right, so I know we started with 1, and then the next term was a half times the previous, which is 0.5, and then 0.25, and so on. So this continues. And in this column, what I'll write is the sum. So let me just put in a new line. So this is UN, and then this one here, come on, UN, and this one here is SN. So what I mean by SN is this one will be S1. So we can see what that is. If you just add the first term together, what do you get? It's just going to be 1, isn't it? Yeah, so if I just do the sum of the first one, which is A2 to A2, I'll just get 1. What should I get for the next one when I do sum? What should I get? A2 to A3. If I add the first 2, what do I get? 1.5, yeah, very good. And then if I add the first 3, what do I get? 1.75. So let's keep going down. No, it doesn't look like it. So if I just go a couple of hundred in. Now I know it looks like it's 2, but that's because of the rounding. It's actually 1.99999. There's many of them. But if you see here that it practically gets the 2 at around about S30. Okay, but this is definitely convergent. So even though you're adding many terms together, infinite number of terms, this will total up to 2. So let's see what happens if we try to use our formula for infinity. You know the formula Sn is A 1 minus or n over 1 minus or. But what about if I put in n is infinity? Well, the A is still A. Yeah, the problem is here, yeah, this will be or infinity. Now, what exactly is that? Does anyone know? It's not, it depends. It depends on the value for r. So, watch what happens here. You could try this out on your calculator, but if you type in something like power, let's say 0.5, and I know we can't put in infinity. Infinity is too big to put in. So we'll put in the next best thing, which is 100, which is pretty big. It's just nearly the same. Right, so if I have 0.5 power 100, oh wait, I don't, maybe the function is in power. Sorry, I forgot. 0.5 power 100. Now this number is tiny. This means 31 zeros. So 0.000031 times. And if I just make the power bigger, it's going to make it smaller and smaller. So if you have power infinity, it looks like it makes it 0. But what happens if I put in a number like 2? So 2 power 100. Now that's a really big number. So what's the difference? Well, the difference is, in the first case, when you have a number less than 1, like for example, let's say 0.5, when you have a very large power, what you're doing is you're doing 0.5 multiplied by itself many times. Each time you multiply by 0.5, do you get bigger or smaller? Smaller. And if we have 2 to a large power, what's it going to be? It's going to be large as well. So, as long as the OR is small, and by small I mean between -1 and 1, as long as we have that, then we have this formula for the infinite sum, A over 1 minus OR. And this is important. Okay. So this is the formula for this one. Can I go, did I have an example written here? I did, yeah. Okay, so if I just go back to my example. So let's test my formula to see if I do get 2. So what's the A? It's a 1. And what's the OR? A half. And if you type that in, you do get 2. So my formula works. Okay. Now, let's say I had this infinite sum. 2 plus 4 plus 8 plus 16 plus 32. This is geometric, of course. Will this have a limit? What do you think? No, this is not convergent. This is divergent. And in the exam, they often ask you, is it convergent or divergent, and why? So the answer here, this is divergent, and the reason is simple. The reason is because OR equals 2, which is bigger than 1. So if the OR is a number between -1 and +1, it's going to converge and have a limit. But if the OR is outside of this, like if in this case 2, it's too big and it diverges. So instead of getting smaller and smaller, this sequence is getting bigger and bigger. And here, because the OR is a half, which is less than 1, the sequence is getting smaller and smaller. So this one is convergent, whereas my second example here is divergent.
Question.
Yeah.
Can you let that answer is plus infinity?
Yeah, it's like the answer is plus infinity in this case, but not in all cases. Okay, did you write that down? Yeah. So just remember, this is a typical 1-mark question in the exam where they give you a series like this and they'd ask you, is it convergent and or divergent? And all they want for 1 mark is to say divergent because OR equals 2, which is greater than 1. Or in this case, what would you say here? Convergent because? Yeah, OR equals a half, and a half is bigger than -1 but smaller than 1. This is just for 1 mark in the exam, this sentence. But whoever writes the exam, they like asking this. And usually it's because they're making a question and it needs to total 20 marks and they need to think of 1 extra mark to make the total 20. So this is the types of questions that they think of for 1 mark. Okay. Right, let's have a look at another convergent one.
So if
Yep.
the numbers are not between 1 minus 1
Mhm.
and 1, then they don't have limits.
That's right. Limits are only if they're convergent, and I don't think I stressed this, but yes, this is called the limit. The answer here. It's what it's moving to. Yeah. Okay, let's have a look at another type. Can I scroll down? Yeah. Right. So what I want you to do, and you can use your calculator to help you. I'm going to give you a sequence. What type of sequence is this? What's it called? Does anyone remember its name? Recursive. Yeah. Give me the first 5 terms, please, of this. You can use your calculator. Okay, so if you're using your calculator, you should have the first 5 terms. If you don't, that's okay. I've calculated them for you. So there's the first 5 terms. Let me zoom in a little bit for you. Okay. Can you see those there? They're my first 5 terms of this sequence. The first term I gave you, I said the first term was 3. Yeah, we did this last week, I think, was it, the recursive sequences? So let's calculate some more terms. Let's go up to term 10, and let's go up to term 20. So for this sequence, we can see clearly it is convergent, and in fact, you can also clearly see what's the limit here. It's 6, isn't it? And in fact, even after term 5, you could nearly guess that it's moving to the limit is 6. Yeah, it's moving around the 6 mark, isn't it? Now, we had no guarantee of knowing that was 6. It could have been 6.1. It just looks like it's around about 6. So we want to find a way to, so let me just actually forget about, well actually no, we can leave this here, I think. So we want to find a way to calculate the limit exactly, okay? So we can actually find it from this formula. I don't know if anybody has seen this before, but I'll give you the hint anyways. What you need to be looking at is not the result that we're getting to the end, but we should look at the relationship between the neighbours. So if I look at 3 and then if I look at 7, hang on, they're quite far apart, aren't they? The difference is 4. Now if I move along a little bit, there's 6.0006 and 5.99. What would you say about their difference? They're smaller, yeah? And as I move further down, like here and here, what's happening to the difference between the neighbours? It's smaller and smaller, yeah? In fact, because of rounding off, it looks like the difference here is 0 and that they're the same, yeah? Now we all know it's not exactly the same. There's a small difference, but it looks nearly the same. So in our mind, what we do is we imagine we've moved down to a very large n. If n is very large, what can we say about the neighbours? Well, we can say that the neighbours are the same value. So that means un is roughly the same as un minus 1. Can you see my point I'm making? That if we call this un, then its previous value un minus 1 is the same practically. So if I go to my formula, I can say this is x equals 5 plus 6 over x. What I'm doing is I'm calling both of these equal to something like x. We don't know what the x is, that's the point. The point is we want to find this x. When I look at my spreadsheet, I can see that the x is 6. This is the number that they're both trying to share. But when I look at this, you realize, oh, now my life is much easier. If I solve this, I can find the x. Now that's not too difficult to solve. Does anybody know what I should do first to solve this? No. Multiply by x. So this becomes x squared equals 5x plus 6. So this becomes x squared minus 5x minus 6. Which becomes x minus 3. No, sorry, 6 and 1, isn't it? X minus 6 and x plus 1. So we have two values here for x, minus 1 or 6. Does one of those values look familiar? Yeah. Now, this is the thing. You need to calculate the first 5 terms because we have no way of knowing which is the right limit here. Could it be minus 1 or could it be 6? So in the exam, you're going to need to calculate at least the first 5. After the first 5, if I said to you, okay, which is the limit, minus 1 or 6? Well, I hope you can all see that you should choose 6 because clearly this is moving to 6. It's not moving to minus 1. So what we can say is we can reject this answer and this is the limit. The limit is 6. So what about the minus 1? Is it totally wrong, or does anyone have any ideas about the minus 1, how it could make sense? Well, the minus 1 is a possible answer. It depends on what you take as the first term. So watch this. This is actually interesting. If I go back here, if I change the first term, I'll still get the same limit. Watch, if I start at 4 instead of 3, I still move towards 6. In fact, I get there sooner. Look at this again. I get to 6 at about the 11th term. If I change this to 4, can you see I got there sooner? And what about if I change it to 5? Well, it was about the same, a little bit sooner. Here it is here. Okay, now I expand it so we can see more decimal places. Okay, let me just shrink this a little bit. So what about if I start at a really, really big number, far away from 6? So I start at 1,000. Will we still get to 6? What do you think?
Yeah.
We'll still get to 6, but... And we still got there... Oh, hang on. Oh, no, wait. This is why... Yeah, no, this is it. Oh, okay, let's start at a really big number, 1,000,000. Still getting there. Right? Now, the reason for why it doesn't really matter is because if you look at the formula, we have 6 divided by the previous term. If the previous term is actually really, really big, then what are we adding to 5? A really, really small number. So in fact, if I want to take a longer time to get to 6, I shouldn't start at a really big number. I should start at like a really small number. Like this. But I still get to 6 pretty quick. Because if this is really small, what will this be in total? Big. Add it to 5? Big. But if I put a big number into the next one, then you'll have 6 over a big number, which makes it back to small again. So it doesn't matter, it doesn't really matter what number I put in here, 250, I'll still get the 6 pretty quick. Can you see that? Now, I said the second answer here, minus 1, has a meaning. It might be possible to get to minus 1 as a second answer if we choose the right starting number. So I probably should start at least at a minus number. Let's see if I start at minus 2, can I get to minus 1? No, I still get to 6. If I start at minus 1.1, maybe this will take me to minus 1. No, it still takes me to 6. Okay, yeah?
But I think you can get minus when you are descending order. Your sequence is descending.
Well, let's just put in minus 0.9. And I still get to 6.
Depends on the nature of.
Yeah, but for this particular one, it looks like there's no way I can get to minus 1. I can always only land on 6. There's only one way I can get to minus 1, and that's if I start at minus 1. What's going to happen to the sequence? Any ideas? If I start at minus 1, I've reached the limit, and they're all going to be minus 1. If I start at 6, they're all 6 then. If I start at minus 1.00001, 6. Yeah. So we can see that our sequence really wants to move to this as the limit and really avoids this answer. Okay. So this is not a limit. I can't even make it get to minus 1. I can only make it get to 6. Okay. So clearly 6 is the choice to make here. Okay. Let's have a look at another type of problem. This, by the way, is a pretty common question in the exam. Like, I would say I've seen this type of question half the time on the exam. Okay, so this is a common limit question on the exam, so please make sure you write this down carefully. Let's have a look at the next type. Can I scroll down now? Yeah.
This kind of question, what is the question?
The question is just find the limit. So the question would say, find the limit of this sequence if we start at 3. But I hope you realize that the starting point is not too important, because even when I changed it, I still ended up at 6. Yeah. Okay. Scroll down. Yeah. Right, let's have a look at the next type. So we did recursive. So again, what I want you to do is give me the first 5 terms. We'll say this sequence. Un equals 6n squared minus 7n minus 6 over 3n squared minus 5n. So this is an easier formula to use. I want you to use n as 1, 2, 3, 4, 5 and give me the first 5 terms. Okay, let me just type into Excel as well. So here is my n and here is my un. And my formula is something divided by something, and on the top I have 6 times n squared minus 7 times n plus 8 over 3 times n squared minus 5 times n. So what did you get for the first term?
3.5.
Minus 3.5? Then what did I type in wrong here? Because 6n squared minus 7n plus... Oh, I wrote minus 6. Sorry. Minus 6. 3.5, yeah? Okay. And the next one? 2? 2.25, 2.214, 2.18. So, convergent or divergent? Convergent, and the limit, what do we think? might be 2, but like I said, it could be like 2.1 or something. So I'll scroll down to, let's say, the 100th term. Well, that'll be enough. Yeah, so it looks like it's probably moving towards 2 as the limit. So, I'll just delete these here, yeah?
So that you have gone to 2 before. This is 2, so how is it getting to 3 if it has already reached?
Well, that's the other thing too, like, if it's already reached 2, then it left 2 and it's coming back. So it might not be 2, it might be just something really close to 2, yeah. We'll calculate it now, but from looking at it, I think it will be 2. So it is a bit weird that it hit 2, left it, and then it's going back to it, yes. Okay. Right. So here we want to calculate the limit, so we want to put in n is very, very large. Now we could actually try to put in a large number, but then it doesn't really work. Like if I put in infinity, you see that what I get just completely doesn't make sense. It just doesn't make sense. Yeah, infinity over infinity. It doesn't make sense. But there is a way you can simplify this so that when you do put in a large n, it makes sense. And the trick here is to divide the top and bottom by n squared. So on the top, 6n squared divided by n squared is 6. And then 7n divided by n squared? 7 over n minus 6 over n squared. And then that's 3 minus 5 over n. Now, when you do put in a large value of n, you'll get 6 minus 7 over large value minus 6 over large value squared over 3 minus 5 over a large value. Now these all make sense. If I have 7 divided by an extremely large number, what will this become? 0. 6 divided by a large number squared, definitely 0. And here, 0. So all of these become really unimportant as n gets large, meaning only the first numbers here really matter in the end, the 6 and the 3, leaving me with 6 over 3, which is 2, which is what we taught anyways. Okay. So the trick here is to divide by the biggest n power. So if this was n cubed, then you would divide everything by n cubed. Yeah. Okay. One last type of question to do here. Can I scroll down? Yeah. Okay, so the last type of question is we can use limits to write numbers which are repeating as fractions. So for example, if I have a number like 0.121212 dot 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 dot, whenever a sequence repeats like this, a number repeats like this, we know that it's rational. That means we know that we can write it like a fraction. So a very simple example, the first one that you learn in school, is when the number 3 repeats itself, we know that this equals 1 over 3 then. Okay? But if I said something like, I don't know, like 121212, it's not clear what that fraction is. Okay, so I'll show you how to write this as a fraction. I've seen this question in the exam only once, so it's not likely to come up in the exam, but it has been asked, which means that if you were a student taking the exam that year, you would have this question that you haven't seen before. So, even though it's not likely, it's good to see questions which aren't likely. Let's have a look at this one. So what you do first for simplifying this is you split it into each 12. So what I mean is you write it as 0.12 plus 0.0012 plus 0.000012, etc. Dot, dot, dot. So I'm just pulling the 12s out separately as different numbers. So this one is the first one, this is the second one, and this third one, and so on. Okay, so write that bit down, and then what we do next is we write each of them as a fraction. So this one is 12 over 100. This one here is 12 over, I believe, 10,000, isn't it? Or 1,000. Oh dear. 1, 2, 3, 4. 10,000, yes. And this one here be 12 over 1,000,000, etc. Now, and actually, if you're a little bit shaky on that, I wonder if you type it into the calculator, will it convert it? Yes. Okay, so next, what you notice is that, well, these are nearly all the same, except the only difference between the neighbours is that it gets smaller. In fact, each time I'm multiplying by 1 over 100. So what type of sequence is this, where you multiply by the same number? Geometric. This is actually a geometric sequence, where the A equals 12 over 100 and the OR equals 1 over 100. And is this an infinite sum? It is. It's infinite. So we can use that formula I gave you at the start of the class. So the infinite formula, A over 1 minus OR. So that equals 12 over 100 over 1 minus 1 over 100. That's equal to 12 over 100 over 99 over 100. Well, those hundreds cancel, which is nice. So you're left with 12 over 99 as the answer. Now, if you type that into your calculator, see what you get. 12 divided by 99. And you get, as a decimal, yeah, you get what we're looking for. I'll just put it here for you so you can see. If I type in, what was it, 12 over 99, I get it. Yeah. Actually, sorry, that 12 over 99 can be simplified, can't it? 4 over 30? 3, yeah. You're dividing by 3, yeah. So this is the answer here. It's not really a limit. What you're doing is you're rewriting a decimal, which is infinite, as a fraction.
You have to just write 1, 1, 2, 1, 2, 1, 2, 1, 2, 1.
Yeah.
Calculate and then you press A over B by A.
Oh, it can convert it for you?
Yeah, it gives it to you as 4 over 30.
Great, so I tell you what, if you do that in the exam, I'll give the marks to your calculator since it did all the work. So that's fine to check your answer, but don't do that in the exam, okay? Okay, did you write this one down? Yeah. Let's have a look here. So, just before we finish, just something to say about your coursework. In the previous lesson, there were, I think, 10 questions on the page, but I just want to draw your attention. You don't have to look at it now, but just for later tonight or whenever you're looking at it. There's a question, the last question, question 10. It looks a bit tricky, but I think it's good if you at least try the last one, because it is very much related to your coursework, okay? And I think possibly as well, if I just check some other previous yeah, I'll just tell you this, wait. So just listen. The last question on the GP worksheet and the general formula worksheet both those questions are very similar to things that you have to do in your coursework. So I know they're a bit difficult, but I do recommend that you really try to figure them out because it'll help you with your coursework project when you start it, okay? So for this homework for tonight, you can probably just do, I think, A and B as well. Let me just double check. No, triple homework because you have class later. So just I wouldn't only give you double. I care too much about you. Triple. Right. A and B in each.
Yeah, but the last, you said to try which one?
The last question in the GP. No, I said you should try it even though it's difficult. GP and general formula. Yeah. Okay, we'll finish there. A and B you should try for homework on the limits worksheet. Oh, do you need to write this down? Can I close it?